and welcome to episode 71 of ERRX. In this three-part mini Grand Round series, we're going to talk about phenobarbital and its use in alcohol withdrawal. Similar to what I did back in episodes 46 through 48, in each episode I'll focus on a specific aspect of phenobarb. In part 1 this week, I wanted to discuss how we got phenobarb and how it works on a molecular level for treating and preventing seizures, and why it's beneficial in the setting of alcohol withdrawal. The first medical use of a barbiturate happened in Germany in 1903, when Emil Fischer and Joseph von Mering found that giving dogs barbital made them tired. Soon after, the pharmaceutical company Bayer started marketing the drug as a sedative hypnotic called Veronal. In 1911, phenobarbital itself was created, and by 1912, Bayer again took the opportunity to bring it to market as a sedative under the trade name Luminol. It's crazy to think that this was all well before the time of drug trials, and many meds were just put on the market without much safety or efficacy data. The discovery of phenobarb's anti-epileptic actions is kind of funny. Legend has it that in 1912, Alfred Hauptmann, a young German clinical assistant, was living above an epilepsy ward. He kept getting woken up by the seizing patients at night, so he gave them phenobarb as a sedative to help them fall asleep and stay asleep. But he noticed that giving them phenobarb also stopped them from having seizures. This kicked off Hauptmann's curiosity, and he started giving more and more epileptic patients phenobarb, noticing that it helped patients with even the most severe cases of epilepsy, including status epilepticus. Remember that phenobarb is still to this day recommended as a second-line agent for both the emergent and urgent phases of status treatment, and it can also be used for refractory cases. By 1919, Hauptmann was recommending it for the treatment of epilepsy and status, but the drug didn't get much attention given that whole World War I thing that happened, briefly stopping the exchange of medical information internationally, and because the drug was still only available in Germany. By the 1920s, it was being manufactured in Britain and even made its way to the US, but it was little used and mostly left to the margins of epilepsy literature, alongside things like zinc, nitroglycerin, subarachnoid air injections, and the ketogenic diet. It wasn't widely used until the 1940s, around the same time we got phenytoin, both of which were heavily used until the late 1970s, when they were both replaced as first-line options by carbamazepine and valproate. With that background, I'm going to shift gears a bit and talk about phenobarb in a related but slightly different context, using it to manage alcohol withdrawal. To do this, let's go back to Pharmacology 101. Excitatory neurons work by depolarizing the cell through an influx of positively charged sodium and calcium ions, setting off an action potential. This causes the release of the excitatory neurotransmitter glutamate. Glutamate then binds AMPA and NMDA receptors, causing sodium and calcium ions, respectively, to enter the next neuron and propagate the excitatory signal. If you have too many excitatory signals and too much glutamate, this can lead to things like seizures. So to balance this out, our bodies also have inhibitory neurons that release an inhibitory neurotransmitter called GABA. You may have heard of it, which binds to the neuron, but instead it binds the GABA A receptor. When this happens, the GABA A receptor's chloride channel opens and negatively charged chloride ions rush into the cell, causing hyperpolarization, making it harder for an excitatory signal to propagate an action potential, basically chilling us out. Okay, so how does this tie into alcohol or ethanol use? On the GABA A receptor, there is a specific binding site for ethanol, and when it binds, it activates those inhibitory GABA receptors. Chronic use leads to an insensitivity to GABA and a decrease of GABA A receptors, meaning that more inhibitory signals are needed for the GABA A receptor to open, cause hyperpolarization, and send an inhibitory signal. This is why chronic alcoholics can walk around with ethanol levels that could literally kill a person who doesn't drink. Alcohol also inhibits those excitatory neurotransmitters like glutamate, and in response, our bodies increase the number of glutamate receptors to maintain a balance between inhibitory and excitatory signals. In an alcoholic patient, only the constant intake of ethanol keeps the scales balanced. When those patients suddenly stop drinking, they take away the inhibitory signals, but since they now have many more excitatory receptors, this leads to an overload of excitatory signals and the common symptoms of alcohol withdrawal we see, including seizures. So how does Phenobarb help with alcohol withdrawal symptoms? Phenobarb and other barbiturates bind the GABA-A receptor at a different site than the neurotransmitter GABA, which is actually even a different site than the benzodiazepines use. It potentiates the effect of GABA by increasing the duration the GABA-A receptor stays open, allowing chloride to rush in. And like alcohol, it can also decrease the activity of excitatory neurotransmitters like glutamate, really increasing that inhibitory signal. I should mention that benzos work by increasing the frequency, not duration, of GABA-A receptor opening, and this nuanced difference in mechanism of action can be additive and is why combining Phenobarb with benzos can increase the risk of airway and other complications, something we'll discuss again in the next episodes. Intravenous Phenobarb has an almost perfect and very predictable pharmacokinetic profile in the setting of alcohol withdrawal. It has a very quick onset of action of about 5 minutes that peaks at about 15 minutes. It has a long duration of action with a half-life of about 80 hours, which is very useful because it self-tapers and causes a smooth transition off just in time for withdrawal symptoms to resolve. Sometimes patients do very well with just one big upfront loading dose of Phenobarb, removing the need for constant CWAS scoring and reactive benzo dosing. We can also predict serum Phenobarb levels based on the dose given, and we can check levels if we are worried about toxicity, something we can't do with benzos, but more on these points in the next episodes. As always, thank you so much for your time. Tune in next time for part 2 of the series, where I'll discuss some studies using Phenobarb for alcohol withdrawal, my site's own Phenobarb protocol, and some recommendations for dosing and monitoring. I also want to take this time to shout out Kayla and Stephanie for supporting the show on buymeacoffee.com. Thank you. Every dollar donated goes to bills to keep the show running and free for everyone. You can find a link to the donations in the show notes.